a plus b whole square, a square plus b square plus 2ab upon q square plus 1, 225 upon 117. So we get 1 plus 2q upon q square plus 1, 225 upon 117. So 2q upon q square plus 1, 225, 117 minus 1. After taking LCM, we get 12 upon 13. So in the next step, q square plus 1 upon 2q is 13 by 12. It is again a quadratic. 12q square plus 12, 26q. Or we can apply here componendo and dividendo. 1 plus q square plus 2q, 1 plus q square minus 2q, 13 plus 12 upon 13 minus 12. We have applied componendo and dividendo rule here. So this is 1 plus q whole square and 1 minus q whole square. So what we get here, after taking square root, 1 plus q upon 1 minus q is equals to 5. So 5 minus 5q, 6q, 5 minus 1 is 4, 2 by 3. Q has value 2 by 3. So p is 1 minus 2 by 3, 3 minus 2, 1 by 3. Now next we want to find the value of n. Np in plus 1 plus q is equals to 15. Sum of mean and variance is 15. We want to find the value of n. P is 1 by 3. Q is 2 by 3. N 1 by 3. 3 plus 2, 5 by 3 is 15. So n is 3 cube, that is 27. So the required binomial distribution is 27CR, PR, Q is 2 by 3, N minus R, and R has value 0, 1, 2, so on up to 27. Now the next one is question number 9. If the probability of defective bolts is 0.1, find the mean and standard deviation. Find the mean and standard deviation for the distribution of defective bolts. Distribution of defective bolts in total of 500 bolts. If the probability of getting a defective bolt is 0.1, n is 500, minus R, 0, 1, 2, so on up to 8. So it is 8CR 1 by 2, 8 minus R plus R is 8, 0, 1, 2, so on up to 8. Now probability x minus 4 less than equals to 2, minus 2 is less than x minus 4 less than equals to 2, add 4, 4 minus 2 and 4 plus 2 is 6. So probability 2 is less than x less than 6. So it becomes probability x is equals to 2 plus 3, 4, 5 and 6. 2 is less than equals to x, 2k equal, x is 2, so on up to less than equals to 6. So what we get? 8c2 into 1 by 2, 8, 8c3 1 by 2, 8, 8c4 1 by 2, 8 plus 8c5 plus 8c6, 1 by 2 power 8 is common in all, so 8c2 plus 8c3, 8c4, 8c5 and 8c6. So this is our required probability. You can also find the value of these and solve further. Note it down. Now the next one is question number 11. A perfect cubic die, is thrown a large number of times in sets of 8, the occurrence of 5 or 6, is called a success. In what proportion of sets would you expect 3 successes? Would you expect 3 successes? A perfect cubic die is thrown. Probability of getting a 5 or 6 1792 upon 6561. So percentage of total number of sets in which we get 3 successes is 17926561 into n, and so percentage of 3 successes in 100 sets 1792 upon 6561, so 27.31%. Next is question number 12. Find the expectation of number of heads in 15 tosses of coin. So n is 15. Probability of getting a head in a single throw of coin is 1/2. Expectation of x, expectation means mean. So n into p, 15 into 1/2, that is 7.5. Now the next one is, in a game, a man wins a rupee for 6 and loses a rupee for any other number, and loses a rupee for any other number when a fair die is thrown. When a fair die is thrown, the man decided to throw a die. The man decided to throw a die thrice, but to quit as and when he gets 6. Find expected value of amount. Find expected value of amount 16. So 1 by 6 minus 25 and 125 into 3, 375. So 400, 1 by 6 minus 400 upon 216, 36, 10 minus 6, 4, 9 minus 3, so minus 364 upon 216. Note it down. Next one is question number 14.